Hi everyone. I hope you are really excited to learn our first brand new lesson of the semester. I cannot believe it. We're already on Unit 6. We're starting a new lesson. We're starting a new unit, but we are not done with triangles. I'm sure you're so excited about that because we all love triangles. And there's a reason we all love triangles. They have so many cool properties and relationships that we can talk about. And you know what? I know you feel like we've been talking about triangles for a long time, and we have, but there's still so much more to talk about, even more than what we're going to learn in this class. More specifically, we're going to talk about right triangle trigonometry, which is something that not only shows up in this class, but will show up in your pre-calculus class. It'll show up in your calculus class, math classes that you take in college. Trigonometry is a really big part of especially high school math because there's so many cool things that you can do with it. So that's what we're going to talk about. This is our next unit, is about right triangle trigonometry, but we are going to take it a little bit at a time so we can build to the point where we can combine all of these skills together. So trigonometry is basically the geometry of triangles. It comes from two Greek words, trigon or trigon and metron. Trigon means triangle, metron means measure, so we're talking about the measurements in triangles or of triangles. Specifically, we're going to be talking about trigonometric ratios. There's 3 of them that we're going to talk about today, but there's actually 6 in total. But we're going to talk about sine, cosine, and tangent. Sine, cosine, and tangent. And each of these is a trigonometric ratio. And you're like, oh my gosh, you keep saying this. I don't even know what a ratio is. Okay, well, let me tell you. A ratio is just the relationship between two values, and we usually just write those as a fraction, okay? So a trigonometric ratio is the ratio of two sides of a triangle. So we're talking about the lengths of two sides of a triangle written as a fraction because it's a ratio. So the sine of an angle is the ratio of the length of the leg opposite the angle to the length of the hypotenuse. So if I have this triangle here, and I'm talking about sine of A, and you're like, that doesn't say sine, that says sin. It's an abbreviation, right? For example, I don't always write the words feet. I write FT. But if I say somebody is 6 feet tall, I don't say they're 6 feet tall, right? I say 6 feet because it's an abbreviation. So same thing here. When you read this, don't say sin, it's sine, right? So it's the relationship between the opposite side and the hypotenuse. So if I'm talking about this triangle here, if I want to find the sine of angle A, notice that it's angle A, I'm going to take the opposite side, which is side A. Notice that it's a lowercase a. And the hypotenuse, notice that it's a lowercase c. So I set up that ratio. I say sine of angle A is equal to a lowercase a over lowercase c. If you look at this triangle right here, you'll notice that the uppercase letters are the points, whereas the lowercase letters are the measures. An uppercase a and a lowercase a are across from each other. Uppercase b, uppercase c, lowercase c. So anytime you are given measurements and angles, you need to make sure they're set up appropriately. An A always has to be across from an A, and so on and so forth. Now, not only can I take sine of A, I can also take sine of B. Now, if you look in our learning target, it talks about acute angles, and you're like, wait, why does it not say triangles? Well, it's a right triangle, and in any right triangle, the other two angles have to be acute angles. So that's why it says sine of A and B. We're not going to be talking about that right angle because that's not going to hold value to us. If I'm looking for sine of B, I do the same thing, except for I look in relation to angle B. So in relation to angle B, I want the opposite, which is lowercase b, and I still want that same hypotenuse, which is lowercase c. So that's one of the ratios. There's also cosine, which is a relationship between the adjacent leg and the hypotenuse. So it's the adjacent leg over the hypotenuse. When I'm talking about cosine of angle A, I'm going to take the adjacent leg. Adjacent means the leg that touches that angle. And I want the hypotenuse again. So adjacent leg and hypotenuse, which is lowercase b over lowercase c. I can do the same thing for cosine of B, which is adjacent leg, which is A, and hypotenuse, which is C. And again, even though it says cos, we're going to say cosine because we understand that cos is an abbreviation for cosine. And then there's tangent. Tangent has nothing to do with the hypotenuse. Or in its ratio, we do not use the hypotenuse. We use the opposite leg and the adjacent leg. So opposite over adjacent. So if I'm talking about tangent of A, I'm going to go opposite across that triangle, which is lowercase a, and adjacent, which is lowercase b. Now you might be thinking, wait, but C is also adjacent. Yes, but C is the hypotenuse. We're talking about, notice that it says leg. I can do the same thing for angle B. Tangent means opposite, so lowercase b, and adjacent, which is lowercase a. So sine, cosine, and tangent, again, even though it's abbreviated tan, we say tangent. Now, sine, cosine, and tangent, like I said, are the three primary ratios where I talk about opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. But there's actually there's three other relationships as well that you'll learn in your other classes. And those are cosecant of our angle. There's secant of our angle. And there's cotangent of our angle. Now, these are not that important for you to know right now. However, before I finish this, I wanted you to see the ratios, but there's a symbol that I'm about to write that we have not talked about yet. That symbol is a circle with a horizontal line through it. If you're writing it quickly, you might write it like that. Okay, that's how I usually tend to write it. We're going to be using that symbol a lot, and that symbol is the Greek letter theta, and we use that Greek letter theta to represent angles. The same way that we use like that almost looks like a less than sign. So let's draw a triangle out over here, a right triangle. Okay, and let's call this angle our reference angle. So that's our theta. So if I'm talking about theta, this side is going to be our adjacent side. This is obviously our hypotenuse. And across is our opposite side, our opposite leg. So that symbol's theta right there. Let's write that down. Used to denote an unknown measure. Unknown angle measure. So just like you'd use a variable, okay? It's just a Greek letter instead of using like an A or a B. Because we're already using those, kind of get confusing. So a lot of times we use this theta symbol. So this right here, this is called cosecant of theta. Cosecant of theta, which instead of it being opposite leg over hypotenuse, it's actually hypotenuse over opposite leg. Secant of theta is, instead of being adjacent over hypotenuse, it's hypotenuse over adjacent. And cotangent, instead of being opposite leg over adjacent leg, it is adjacent leg over opposite leg. You'll use those later. It's really important for you to know these. And you're like, oh my gosh, I know I'm going to get those mixed up. How am I ever going to remember them? Sohcahtoa to the rescue. Actually, if you look back here, one of the letters back there is a letter from a former student. She's talking about how they're learning trigonometry in her pre-cal class, and she said, Sohcahtoa to the rescue. Okay, Sohcahtoa to the rescue. This S stands for sine, this C stands for cosine, and this T stands for tangent. So let's fill those in. Sine, cosine, and tangent. Okay, to remember the ratio that goes with sine, I say SOH, S-O-H, which is sine is opposite over hypotenuse. Sine of an angle equals opposite over hypotenuse. Cosine of an angle equals adjacent over hypotenuse. And tangent of an angle is opposite leg over adjacent leg. Sohcahtoa. Okay? Maybe you want to write this out all the way so you're not like, what's PP? So now you might be thinking, you're like, what? Why would I even need this? What is this helpful for me for? Well, let's think about the lesson that we just finished learning, right? We just finished learning about special right triangles. And they're called special right triangles because they are special triangles with special properties. Do all right triangles hold those properties? They don't. Only 45, 45, 90 and only 30, 60, 90. But guess what? Those aren't the only types of right triangles in the world. Would be nice, but they're not, right? So we need to make sure that there's a way to solve for side lengths of not special right triangles. So that's where trigonometry comes in, right? That's what mathematicians do. They find ways to solve problems. And you're like, I didn't even know I had those problems. Yeah, but they're out there, right? So it's important for us to have methods and ways to solve these problems. So trigonometry exists to solve for angle measures and side lengths of right triangles that are not 45, 45, 90 and not 30, 60, 90 because we're not that lucky. We're not always going to have 45, 45, 90 and 30, 60, 90 triangles. But we're not going to get into solving just yet. We're just going to practice using Sohcahtoa, sine, cosine, and tangent, creating those ratios, all right? So let's take a look-see. It says, write the trigonometric ratio as a fraction and as a decimal rounded to the nearest 10,000th, okay? Notice that we have two triangles. So I've got triangle JKL and I've got triangle ABC. Now I do want to be wise. Notice, pay attention to which coordinates or which points they're talking about, which vertices they're talking about. So it's saying find the sine of J. Find sine of J. So sine, remember, is equal to opposite over hypotenuse. Opposite over hypotenuse. So sine, so I'm going to find J. Here's J. I want to find the opposite leg. So I'm going to go across my triangle, and that is 60 over hypotenuse. Well, I'm looking for what's across from the 90-degree angle. That is 61. So that's my answer as a fraction. And it also says as a decimal rounded to the nearest 10,000th. So I'm going to grab my calculator. And you are just going to type in that fraction. 60 divided by 61, which is a very long decimal, okay, as is expected. But it says the nearest 10,000th, so that's tenths, hundredths, thousandths, 10,000ths. So I want to go 0.9836, but that's not an exact answer, so I'm going to make sure I say approximately 0.9836. Okay. The next one says cosine of J. So I'm going to go back to this triangle. I'm going to go back to angle J. Cosine. Cosine is adjacent over hypotenuse. So J, what is adjacent to J? Is it 61 or is it 11? It is 11. So let me quickly write this down. Adjacent over hypotenuse. Adjacent is 11 because my hypotenuse is 61, right? So it can't be adjacent if it's the hypotenuse. And also I want to round it to the nearest 10,000th. So I'm going to say approximately, grab my calculator, and all I have to do is type in my fraction. 11 divided by 61, 0.1803. And then tangent of K. Ooh, mixing it up. No more J. We're talking about tangent of K. So K, first of all, is the opposite over the adjacent. So tangent is opposite leg over adjacent leg. Toa. So from K, opposite is 11. Adjacent, is it 60 or is it 61? Remember, 61 is the hypotenuse, so it has to be 60. Nearest 10,000th, so I'm going to pick up my calculator. 11, divided by 60. 0.183 repeating, but it tells us to round, so we are not going to put that repeating symbol. We would never dare. 0.1833. Now what I want you to do is pause this video, and in fact, I'm just going to move this down a little bit so you have it to look at. Pause this video and do these three, and they're talking about this triangle right here. So do that for me. So remember, tangent is opposite over adjacent. We're talking about tangent of A. So I'm going to go to A, opposite over adjacent. 7 over 24, which is approximately 0.2917. Cosine is adjacent over hypotenuse, and we're talking about cosine of, again, angle A. So I go to A. I want to go adjacent, which is 24, and hypotenuse, which is 25, which is approximately 0.9600. And then lastly, sine of B, so I go to B, opposite over hypotenuse, so opposite over hypotenuse, which is 24 over 25. So that's approximately, also 0.9600. Interesting. You're like, wait, how can sine and cosine be the same thing? Well, look, this one's talking about cosine of angle A, and this one's talking about sine of angle B. Okay, now this part right here, you are going to need your calculator for. Not only are you going to need your calculator, you are going to need the app downloaded that we talked about at the beginning of the school year called Calculate 84. Or if you have an Android, it's going to be called WABBIT, Wabbit. You need to have one of those because that's going to be the best replication of one of these calculators for you to access at home. Okay, because right now, I know you guys don't have access to these. So this is going to be the best thing. If you have an iPad that you got from the school, you can download it on there as well. In fact, it should already be there. So you're going to open up the Calculate 84 app. It is pink. I'm going to show you what it looks like. Okay, the Calculate 84 looks like this. It's pink. Let's open that up. You can go ahead and skip anyways. And if you look, it looks almost exactly like our calculators, right? So it says, use your calculator to find the trigonometric ratio. Round to the nearest 10,000th. Be sure your calculator is in degree mode, not in radian mode. Okay, first of all, what we're doing up here is different from what we're doing down here. If you look over here, I did not know the measure of the angle. I was just setting up the fraction that it was equal to, the ratio that it was equal to. Over here, I do know the measure of the angle, okay? So I can substitute in that angle for sine. However, this part is very important right over here. Be sure your calculator is in degree mode, not in radian mode. 52 is a degree measure, 52 degrees, not 52 radians. You'll talk a lot about radians when you take pre-cal and calculus, but right now we're talking about degrees because these are angle measures that are in degrees. 19 degrees, 65 degrees, okay? So you need to put your calculator in something that we call degree mode. And the way that you do that is by, if you look right here, it says mode. You're going to click on mode. And then you're going to scroll. Notice it says radian and degree right over here. Radian and degree. I'm going to scroll down. And I'm going to switch it to degree mode by hitting enter. So I just hover over and I hit enter. Then I can just go back to the home screen by pressing quit. Notice quit is in blue, so I have to press the blue button to access that. Now you can evaluate your trigonometric functions or your trigonometric ratios. On your test, on your homework assignments, you've got to be very careful. There have been times where kids have done the entire assignment in radian mode, okay? Every problem is wrong if you do it in radian mode because that's like making your calculations in centimeters when it should be in feet, right? It is very important that you have it in the right format. So now it says find sine of 52. Well, to do that, it's very easy. If you look carefully right here, I see a sine, I see a cosine, and I see a tangent, okay? Sine, cosine, and tangent. So if I want to do sine of 52, I literally press sine. And between my parentheses, I'm going to type in a 52 and hit enter. That is it, you guys. That's all I have to do. So I'm going to say approximately, because it tells me to round to the nearest 10,000. So approximately 0.788. Do I have to round that 0? I do not. 0.880. Now, I just want to show you really quick what happens if you don't put it into degree mode. So if I go to mode and I leave it in radian mode, if I leave it in radian mode, sine of 52. I'm typing in the exact same thing, but look, your answer is different, okay? And you're like, that's just a little bit different. No, it is not. It is very different, okay? You've got to make sure you are in degree mode. All right. So now let's do cosine of 19. Cosine 19. That's telling you that the angle measure in your triangle is 52 degrees here. The angle measure in your triangle is 19 degrees here. So that is approximately 0.9455. And lastly, tangent of 65. Let's scooch you over. Tangent of 65. Here's the tangent button, 65. So 2.1445. Now, you might freak out and you're like, wait a second, nothing we've done so far has been anything above 1. Okay, that's all right. Nothing wrong with that. 445. So that is it. Okay, if I've got a triangle, these are skills that we're going to use in order to be able to solve all the side lengths and all of the angle measures of triangles. Because if you notice right over here, I don't have any angle measures at all. So we're going to eventually use sine, cosine, and tangent to figure out, hey, what is the measure of angle J? What is the measure of angle K? What is the measure of angle A? What is the measure of angle B? Not only that, we'll be able to take one angle, just one angle, knowing that it's a right triangle, and be able to apply that and find all of the side lengths, all right? So this is going to be something that's really cool that you learn. But right now, like I said, we're going to take it small, itty-bitty steps at a time. All righty. If you've got any questions, make sure you ask during class. Enjoy.